Hello viewers, welcome to my channel. My today's topic is area and perimeter of plane figures. Okay, before I actually tell you the area and perimeter of these kind of figures, I want to give you a little idea about what are actually the plane figures and to what kind of figures we use the word plane figures, right? It is not a new thing, but still I want to make you clear about this kind of figures, right? So, dear students, plane figures are flat two-dimensional figures. Okay, just see, these are the flat two-dimensional figures. Okay, and these figures can have these two-dimensional figures. First of all, I want to tell you, have only the length and the breadth. These are the two-dimensional figures. They have only the length and the breadth with no thickness, right? So these are the flat two-dimensional figures with length and breadth only, no thickness, and these length and breadth, right, or whatever are the dimensions, these two dimensions can be the straight lines or they can be the curved lines also. Okay, they can be straight lines as well as the curved lines, and they have to be only two-dimensional figures. Such figures are called plane figures. And when I will tell you that from junior classes only you have been studying about these, then you will be quite happy to know that the word plane figures might be new, but the figures like, just see, triangles, square, rectangle, okay, and circle are not new to you, right? This rhombus may be a new thing, but still in 8th class, 7th class you start hearing about this. But this triangle, square and rectangle and circle, okay, are not the new ones for you. Okay, already familiar with them, but the actual word for them is plane figures because these are two-dimensional figures with us, right? Now, regarding these, some of these figures, I will today like to tell you about the area and perimeter of those, right? And perimeter also, if we talk about the perimeter of these figures, perimeter again not a new thing. It is only the length of the boundary of a figure, length of the total boundary. Suppose I want to talk about the length of the boundary of this square, then it is simply means adding this side length plus this side length plus this side length and plus this side length will give me its perimeter, right? So perimeter is about the total boundary length only. Perimeter is related to the boundary part of a figure, right? But when we talk about the area, what is area? Perimeter is related to boundary only, but area is the part, is the measure of the surface, is the, what is the this quantity? How do we define this quantity? It is the measure of the surface enclosed by its boundary, right? This boundary is enclosing how much of the surface, that is known as the area of this figure. So perimeter is related to the outside part only, boundary part only, but area is related to the inside part only, right? So this all is about the perimeter and definition part of area and of plane figures. Now we actually come to the area and perimeter of some of these plane figures, and I have here taken up, in this part I will definitely take up the area and perimeter of triangles, right? My first topic is area and perimeter of triangles, right? And when we talk about triangles, I have two options. There. First option is when base and altitude of a triangle are given, right? First option will be when base and altitude of a triangle are given, and second thing which I will discuss today is that when all the three sides of a triangle are given. Okay, these are two different cases, so depending upon the question we will apply the formula. So let us discuss when base and altitude of a triangle are given. Okay, now base, all of you know, I have drawn three examples here, right? For you, I have taken up three examples here. My first part is I have taken up a triangle ABC, normal triangle ABC, right? And I want to take this BC as its base first. Okay, so in this what is the base I have chosen? That is BC. Okay, now base and altitude I said. So the second part I want is the altitude. Now what is the meaning of this altitude? Altitude is always the perpendicular height of a triangle. Okay, altitude is what? Is the perpendicular height of a triangle, right? Perpendicular height means that height of the triangle which drops a perpendicular of 90 degree on our base BC. We have taken up base BC, so corresponding to this base only, students, this is very important point, corresponding to this base BC only we have to drop a perpendicular height. Okay, that have to be drawn always from the opposite vertex. Remember, what is the opposite vertex of base BC? The opposite vertex of base BC is point A. Okay, so from point A we have to drop a perpendicular height. Okay, so here our that perpendicular height, or what is the other word for that? That is called altitude, right? That altitude is what? That AD. Okay, we can call it perpendicular height also, we can call it altitude also. So this is AD, right? So in this case, the area of triangle, the same triangle I am talking about, area of triangle ABC with base BC as the base and AD as the perpendicular height will become what? What is the formula? See here clearly, the formula is half into base into height. Okay, which height? The altitude only or the perpendicular height only. Okay, so in this case that formula will become half base. What is the base here? Base I have written as BC from here, and altitude in this case has been taken up as AD. Altitude has been taken up as AD from the opposite vertex only, and this is the base. Okay, and students, this is not the case. Remember, very important thing, that this is not the case that only BC can be taken as the base. Depending upon the question or the given things, we can take any side of the triangle to be the base. Okay, now in second example only I have taken up AC, the other side of the triangle, to be the base. Okay, so I will write here that let us say base now is AC. If base has changed, accordingly the height will change, and that height from where it will be drawn? Yes, that will be drawn from the opposite vertex only. That opposite vertex is point B here, right? From B I will drop a perpendicular and I will still name it this point as D only. So what will be the altitude here? Altitude here will be BD. In that case, what will be the formula? That formula will be, still the formula will remain. We are talking about the same triangle only, and the formula of the area will remain the same, but only thing is that base and height has changed. So in this case base will be AC and the height now will become as BD. Now in the third case we have taken up the other side. What was the remaining side? That side was AB. In this case base I have taken as AB, and the corresponding height now has changed. The corresponding height or the altitude now will become what? It will become DC only, right? So the another formula will become half base into height, means half AB multiplied by DC. Clear? So this was the all the things when what is given to us when base and altitude of a triangle are given. What is given? When base and altitude of a triangle are given, then this is the concept of finding the area of the triangle. Finally, I am telling you, area in that case will be half base into height only, right? Now the second option depending upon the question can be when all the three sides are given, right? Okay, so that will be totally different case. Here we cannot apply the formula half base into height. Okay, for that we have to take up a totally new formula, right? And that also is very interesting thing. Now the next idea is how to find the area of triangle when all the three sides of a triangle are given. Let those three sides be, lengths of those three sides be small a, small b and small c, and the name of our triangle is ABC only. So our purpose here is to find the area of triangle ABC using the three sides of the triangle. Okay, and the name of that formula is Heron's formula. Okay, what is the name of the formula to be used when the three sides are given? That is Heron's formula. So what actually we are supposed to do while applying this formula, right? So here only I will tell you the formula of perimeter of triangle also, okay, because the topic is area and perimeter. So here only with Heron's formula only I will tell you what is the perimeter of a triangle is nothing but the sum of all the three sides of a triangle. What are those three sides? Sides are A plus B plus C. If we add simply the boundary length only, I will get the perimeter of triangle, right? So this is the perimeter. Simply by adding the boundary length, I will get that total length of the boundary, right? But in Heron's formula, we don't have to use perimeter, but instead we have to use the semi-perimeter. Okay, semi-perimeter, how do we define? It is denoted by the letter S, small s, right? Small s. And what is the formula? It is the half of the perimeter. Semi-perimeter is half of the perimeter. So means the formula is A plus B plus C upon 2 and the symbol used is a small s. Then how do we find the area of the, using small s, how to find the area of triangle ABC? Okay, the formula is again very interesting one, square root of s. S, what is S? S is the semi-perimeter, okay. S is the semi-perimeter into small s into s minus A into s minus B into s minus C. What are ABC here? ABC are the side lengths, small a, small b and small c only, right? Now the next case is, otherwise it is a special case of triangles only, right? So not a new case but a special case only, area of an equilateral triangle. What is the meaning of equilateral triangle? When all the three sides of a triangle are equal. Otherwise, if unequal sides, we can apply the Heron's formula. Even for equal sides, we can apply the Heron's formula, right? But what is the direct formula? Right, that direct formula is area will be square root of 3 upon 4 into side square. Okay, so side, because all the three sides will be equal only, so I have taken up them to be small a only, all the three sides are given to be equal, and the formula will be area is equal to square root of 3 by 4 into side square means a square. So students, very easy and interesting formula, because here simply you have to put the value of side a and you can get. And remember one very important thing, that square root is on 3 only, it is not with 4. Okay, so square root is under the square root sign is 3 only, upon 4 is separate and a square, right? So this was all about equilateral formula. Okay, actually it has come from the Heron's formula only, okay, but we have got a separate direct formula, right? So please remember this. Then another case comes when, special case again, area of an isosceles triangle. Okay, so what is an isosceles triangle? When only two sides of a triangle are equal. When only two sides of a triangle are equal, in that case, the formula again I have written for you, that first of all let me tell you what kind of triangle is this. Because isosceles, so these two sides are equal and base is given to be B. Let B be the length of the base, okay, and A be the length, B be the length of the base, and A be the length of each equal side. A be the length of each equal side. Then what is the area? See, this is the formula, area is equal to B upon 4. B is the base only, B upon 4, square root of 4a square minus b square, right? So what are A, B? A is the length of each equal side, because we are talking about isosceles triangle, and what is B? B is the length of the base only. Okay, so students, that's all about the areas of area and perimeter of these plane figures. And I discussed here, especially in this video, I discussed only the area and perimeter of triangles only. In the next video, I will take up the different more kind of plane figures, right? So if you like my video, now is the time, students, to like, share and subscribe to my channel. do press the bell icon so that you get the notification of my next videos also. Thank you very much for watching.